Okay, we're ready for part 2 of finding side lengths of right triangles when given one side and one angle measurement. What we're doing is solving the right triangle. We want to get all 3 angle measurements. That's the easy part. The sum is 180, this is 90. We're given that this is 50. These two have to add up to be 90. You can write in the 40 right away. This is the one we did before time ran out on the last one. We're given that this side length is 8. Pythagorean theorem would, if we were given 2, we could find the third, but we don't. So as a quick review, what I talked to you about was finding the side that we want to find, and in this case, we're finding the other leg. So we put our pencil on it. This is the side we want to find. This is the opposite. Okay, and we're trying to find the relationship of opposite and adjacent. Here is opposite, and that's our x. We went tangent of 40 because tangent is opposite over adjacent. That's the notes in the little chart that I gave you above. Tangent of 40 degrees is equal to x over 8. Because the number that we're finding is in the numerator, we multiply both sides by 8. So 8 times tangent 40. When you do that math, x will equal 6.71. And that's the length of this side. Okay, so that's your short review of what we did at the end of the last video. Okay, so now the question is, let's find the hypotenuse. You can choose either angle as your reference angle. It doesn't matter. I'll tell you my thinking. I usually take the side that we know that's a nice easy number, which is 8, and I use that. And then I usually use the the angle opposite that, which would be 50. So which relationship, if we're using 50 and we're using 8, which is the opposite side, which relationship has opposite over hypotenuse? We're trying to use the opposite side and the hypotenuse. That's our sine. Look up at your chart up above, and it will be sine. So our formula is going to be, or our equation is going to be sine 50, because we're using this angle, the sine of 50 degrees, opposite over hypotenuse. 8 over y. Now, our variable's in the denominator this time, which is different than the last time. And so we're going to be doing something different. I'm going to kind of use a shortcut method right now. If we multiplied both sides by y and then divided both sides by sine 50, that's what we do kind of longhand. All we do is swap out those two terms. So it becomes y equals 8 divided by sine 50. Because if we multiplied both sides by y would come over here and cancel, and then we would divide by sine 50 to get y by itself. So y is equal to 8 divided by sine 50, and that will give you this length right here. Sorry for that little pause in action right there. I'll do the math for you. 8 divided by sine 50, and you get 10.4. And that's the length of the hypotenuse. Okay? You could always do a check of 8 squared plus 6 squared equals 10 squared. And that might give you a check to make sure you're good on that. So what we did was our section in the notes that said how to find the hypotenuse, determine which angle to use. I chose 50 because it's opposite 8. And then this is the opposite in the hypotenuse, so I used sine on that. Okay, and then the other key teaching point was when the variables in the denominator, I can't stress this enough, everybody, this is gonna be important. Really, switch these out, swap them out, so y equals 8 divided by sine 50. Since I have your attention, I will show you another way that you could have done it. I could have used 40 as my reference angle. And maybe I wanted to use 8 again as the side that I use. Well, 8 is the adjacent side of 40. So what relationship uses adjacent over hypotenuse? That's our cosine. Cosine is the relationship. So I could have done cosine 40 equals adjacent 8 over hypotenuse y. And then swap these out because this is in the denominator. Y equals 8 divided by cosine 40. And if you did that math, you would get the same answer, 10.4. So that's the interesting thing about this is you could use different relationships, sine or cosine, with the different identifying angles and still get the right answer. Okay, so that's going to be some of the aspects. Your neighbor might use a different relationship than you for that. So that gets us into the right triangle piece. You can use a lot of different you could use sine, cosine, or tangent. It doesn't matter right away. And that's the part that sometimes is difficult for students. So let's take our time on these. When we're given this, which one do we want to do? We could find the hypotenuse first if we wanted to. I always suggest finding the other leg first, but we could have found the hypotenuse first on that, and then we could have found the other leg. So we're going to have some practice on the back of this note paper. Are some practice problems, and we start to solve the right triangles, which is find the lengths, and at the end you should have all three side lengths and all three angle measurements.